Scientific theories must be based on facts, not on assumptions. Because if someone finds out that the assumption was false, the whole theory is refuted. Welcome to Red Hill, the top of the Haleakala volcano. An ideal place to expose the false Earth curvature. There is one fundamental aspect of the spherical Earth model that remains an assumption. Because there is no documented record of a distant mountain higher than the observer, falling below eye level. If the Earth were really a globe, this phenomenon would be widely confirmed by disciplines such as geodesy and topography. But this is not the case. What happens is that distant mountains higher than the observer do not drop below eye level. They stay up. These are the facts. Mount Kea peak is 1,150 meters higher than the observation point. And it turns out that its top should drop to eye level, according to the globe numbers. The reality is that it is 0.51 degrees higher, as predicted by trigonometry on a plane. And this fact is recorded daily by hundreds of tourists who visit the site. Here is a simple but highly effective method for determining eye level in any panorama that has a Haleakala-like configuration. The observation point must be a high peak to obtain long-range visuals. Then, we must have a nearby peak that is slightly smaller than the observation point. And finally, another distant peak in the background that will be higher than the observation point. This is exactly the scenario we have in Hawaii. The observation point at the top of Haleakala. The magnetic peak at about 270 meters. And Mauna Kea is the highest and distant mountain at about 128.3 kilometers. Now note that between eye level and the nearby peak the angle delta 1 is formed. The delta 1 of the flat Earth and the delta 1 of the globe Earth are equal. And that is the strength of the method. Because no matter which of the two models is true, the eye level is always going to be delta 1 above the nearby peak. Knowing this, you just have to check what happens with the distant peak in a real panorama, if it stays above it, or if it falls. In the plane, we have a positive delta 2 above eye level. But in the sphere, delta 2 is 0. both delta 1 are equal and what changes are what we see in the background. On the flat Earth, we have delta 2 to the top of the far mountain. But on globe Earth, there is no positive delta 2 because the distant mountain fell due to curvature. Another advantage of this method is that it does not require the lens to be level. The relationship between eye level and external references is preserved whether the camera is tilted up or down when taking the shot. Let's verify the reality captured by a lens located in the Haleakala 3,055 meters above sea level, in front of the south-southeast window of the observatory, with a height above the ground of 1.70 meters. And this is the panorama you get. I leave the equations here to calculate delta 1. Peak heights are public domain data provided by the United States USGS. And officially the magnetic peak is 10,016 feet, which is equivalent to 3,052.87 meters. Even the USGS digital elevation module offers a slightly higher value of 3,052.97 meters, but we will use the official data rounded to 3,052.9 meters. We substitute the data in the equation and delta 1 is 0.8063 degrees. We already know that in this capture the eye level is 0.8 degrees above the magnetic peak. We still need to know what portion of this image is equivalent to 0.8 degrees, and to represent angles we have to build a scale. It turns out that between the top of Mount Kea and a small peak called Haleakala there is 0.8083 degrees. That means that in any photo taken from the Haleakala where these two points are seen, we will know that they mean 0.8 degrees. We move that 0.8 degrees to the top of the magnetic peak to see where eye level is. And here it is. And as you can see, Mount Kea is above. Does not fall. There is an angle delta 2 to its top equal to 0.1, 0.2, 0.3, 0.4, and 0.518 degrees, right where you would expect it to be on a flat surface with no curvature. Today's panorama generators are very accurate but assume that the Earth is a globe with distant mountains falling through the curvature. But since the Earth is not a globe, the generator will have a great conflict when asked to show a panorama like the one from the south-southeast window of the top of Haleakala. And it has no other choice but to lie grossly, exposing the falsity of the globe Earth. The software drops Mount Kea down to eye level because that's what it's designed to do. Then place the horizon above magnetic peak. And this is a lie, because in the ball Earth the horizon would have to be seen below this peak. What happens is that in reality the horizon is normally observed above the magnetic peak, but this is a consequence of the flat Earth, not the globe. Lastly, remember that from this point you have to see a delta 1 of 0.88 degrees between the magnetic peak and eye level, both on the flat Earth and on the globe, and that is a geometric truth that should not be violated. Ooh, what's going on here? Well, as you can see, the panorama generator has no choice but to invent a delta 1 much larger than 0.88 degrees so that all the lies fit in there. You can check it out for yourself. Although the generator does not have an angle scale on the horizontal axis, which is very convenient to hide these fakes, it does have a vertical scale of 1 degree, so you borrow the vertical scale and you turn it. You place it below eye level and we see how much they had to increase the angle delta 1. Almost triple. In front of the north-northeast window, outside the observatory is another popular spot for panorama viewing, and from there, you can apply the same method, you just have to consider the change of variables. The distance to magnetic peak increases by 10 meters and the height of the lens decreases by 1 meter from the previous observation point. We substitute the data and from this point, delta 1 is equal to 0.578 degrees. We identify the points that offer us the 0.88 degrees scale. And we transported the scale up to magnetic peak. Again we get Mount Kea 0.518 degrees above eye level as predicted on flat Earth. Let's superimpose on the image the sunrise time-lapse that was taken from the same place to verify if the horizon that can be seen above the magnetic peak coincides with eye level. perfect match. The horizon coincides with eye level at 3,055 meters above sea level. The Earth is overwhelmingly flat.